Hi, welcome. Thank you for tuning in. I'm sorry about the slight echo you can hear in my audio. I'm having a little bit of issues with getting rid of the echo in this room, so please bear with me today. Um, Thank you for joining. I am very happy that you all are here. Please say hi in the chat so I know who's here and would love to meet all of you. In case you don't know, my name is Jayne Mast, and I am the engineering manager over at Daily, which is what the channel is all about. So, in case you've missed it, we've been doing a series of explainers where I talk about um, how we built the spatialization demo. I basically meant Lisa because she built most of it. So this will be part 7, and that will be the final part of the spatialization demos. And after that, I will go on vacation for a couple of weeks. So it will be the last stream for a little while. We'll be back after that with lots of new content, maybe some guests who arrive here and there. And I will also continue on one of the other streams that I'm doing where I'm trying to recreate OBS using Daily. So that's fun. Yeah. So switching cameras. Now I cannot really see the chat anymore, but that's okay. So let's talk a little bit about what we're doing again. So this is our blog where we posted all the blog posts about the spatialization demo. And we've gone through all of them except for this 7th part, where we're going to talk about spatialization features with robots and Jest. So we're doing manual and automated testing of the audio and video features. So that could be very exciting because it can be pretty difficult to test video and audio if you're not used to doing it. So I hope you can learn a little bit from this. In case you don't know what the spatialization demo is, let me just show you real quick what it's all about. So we have this page, the login page. You enter your name and the daily room that you want to join. And then you click Start Demo. And here you are in this 2D environment where you can walk around with the arrow keys or with WASD, and you can talk to each other. You can broadcast to everyone who's around, or you can have specific rooms where you only hear each other in that room or the person that's broadcasting. And there's a few buttons at the bottom where you can turn off your video, where you can turn off your audio, and where you can start screen sharing. But not only that, you can also hear each other when someone is far away, you don't hear them, and the closer they are, the better the audio becomes. And let me show you a little bit. I'm going to use my actual first name here for the second person. So you can see Jayne is now sort of semi-opaque. If I walk closer, then it becomes clearer and clearer, and then wait, did I still have my... Oh yeah, and then you don't see each other, but you will see each other here, I guess. Somehow my video is not working. I did some weird things today with my video. So maybe video sharing is not working right now. Let me quickly check. There's always something going on, right? So this is the when I was running it, doesn't seem to be that there are any errors here. So let me quickly check in. could just be that I'm on like an older version or something. Not an older version of the... there it is. I just had some data cached that wasn't really working well. Demos, right? So as you can see, I need to refresh these two as well, then of course, because they are also still, while it's on this, they also have still the cached versions of it. I need to do like this, and that should work, I guess. Someone here. Yes, everybody's here now. Okay, that's much better. There you go. You can see how the people, how the other versions of me pop in and out. I need to mute my notifications because I don't need to know if I don't want to bother you with my buzz. So turn off my notifications. Sorry about that. So you can see here that you can walk around and you don't see the others when you go into a room. But if someone is broadcasting, you will still see them on the left side. So here's Jayne. This is me, Marcia. Then there's Mast over there. So you can see that this person only sees himself. And these people see the other versions of me as well. Right, so let's get back into the actual demo. Well, not the actual demo, the actual blog post that we're gonna discuss today. So today we're going into testing our spatialization features. So we've covered a lot of other stuff before, the spatial video and audio implementation, for example, or the focus zones and the screen sharing features. But that's, if you want to see those, they're both on YouTube or on Twitch. Yeah, our demo is written in Typescript and uses Jest as a rendering framework and relies on the Web Audio API for spatial audio features. So we're going to look into a little bit more on the Web Audio API, but mostly mocking it today. So we're going to test the most interesting parts of the application rather than every single feature. And we have two different methods of testing. So we have robots. So these are fake people that can help us test in world features manually. And then we have automated unit tests and integration tests. And we've written that in Jest, but of course you can use any other testing framework as well. So we want to test collision here. We want to test proximity calculation, and we want to test our audio graph. So collision here means if you collide with, for example, one of the focus zones, so that you know if someone is in or out of the focus zone. So let's talk a little bit about robots. So our robots are instances of WebDriver that we host in AWS. And they can join any daily room. We're not gonna really go into how like WebDrivers work, but you can read all about it in Selenium devs environment. And we also have written a blog post in the past on how you can make a headless robot yourself. Also not going into that, but let me know if you are interested in hearing more about this, and I can definitely do a live stream on robots itself. Maybe even convince Vanessa to join the stream at one point to talk about robots. So we have as it says here, we have a couple of handy utilities that will help you spin up a few robots and have them join daily rooms real quick and easy. So let me really just show you how this works. How we would make such a thing. So we have the room class. Let me go back into the room class for a second and show you the code there. Here it is. Closing the rest for a second. Not really sure what it's complaining about right now. Probably because I updated some things again, and now it's complaining about other stuff. So please, I probably need to restart Visual Studio. Just ignore those TypeScript errors for now. They are not there in the real world, just on my machine. So in the room class, we started we created a daily call object for starting all the video calls, and we listened to all the different events that the call object returns. We have a join and a broadcast functions. We set the bandwidth, etc., etc. So in case you kind of forgot what the room did, then maybe this jogs your memory a bit if you have watched one of the previous videos. So the room is handling all communication with daily.js. This means it will be the first thing to encounter a robot. All of the action happens when we receive a participant join event from daily. So that is right here. So when daily returns participant join event, then we go into this handle participant join event function. And as you can see here, we already check if the participant with a certain username is a robot. So we have a quite a weird way to see if it's a robot right now. So it looks up the username and check if the username could be the name of a robot. It's not straightforward, but all of our robots always have an IP address as the name. So you can also sort of fake it, of course, and pretend like you're a robot, but that's not really very useful right now, of course. So this is just how we do the demo. You can maybe do it in a different way yourself. So if the participant appears to be a robot, the room instance calls a special create robot class on the worlds, which happens right here. So it does that instead of the init remote participant and the acknowledgements. It creates a robot and then it returns early. And it gives the session ID of the robot right here. So we'll go through the robot creation in a moment. So we have a few different roles a robot can have. And that is defined somewhere that's not here, but here in the robots TypeScript file. So we have a role that is either world, task, or broadcast. A robot in the world role is tasked with traversing the world. It'll pick a position in the world, go there, wait 10 seconds, then pick another position. As it shows here in the GIF or GIF, or just gonna ignore that. As you can see, the robots don't look very much like human beings, but they look like this fake video with their name on the bottom of it. A robot in the desk role will pick a spot on the desk to navigate to, like you can see here. It goes into the desk role and then leaves the room and enters the room. It will repeatedly leave and enter the spot. Okay, so it will go out and then go back in. And then we have broadcast, so they will move to the broadcast spot, and just with the desk will repeatedly leave and enter it every 10 seconds. And then we can use these behaviors to navigate around the world. Navigate around the robots. So then we want to test things like volume gain, bending, zooming. So you walk around as a human and hear if everything works well. So let's go back to that create robots. Okay, let's go back to it. So this is a thing that is in the world class. So in the world class, it's where we create robots. Why is everything does not exist on broadcast? I am so confused right now, and I'm going to log into this for just a second and see why it's not. It's so weird. Anyway, I'm getting frustrated by it, and I'm gonna close Visual Studio Code for a second and see if that will help. Is it this one? Who knows? That's not the right one. And this one maybe? Hey, this looks better. Yeah, right. Okay, no more annoying red squiggly lines. This is what happens when you change it. So I changed to version 2.0.0 instead of the main branch so that I'm in the same version as the blog post. And I also updated Visual Studio Code, and all of that together is not really working all that well. Oh, just a second. All right, just wanted to see if there was anything in the chat. All right, so back here. So we have this, the world right now. We were talking about create robot, right? Where is the create robot? Create the create robot function here. So we check if we already have a desk and a broadcast robot. So we have a found desk and found broadcast. So this is just to check to know if they are in that specific role, I guess. Check if we already have a desk and a broadcast robot. Yeah. So we go through all the robots, check if one of the robots have the role desks, and then say, yes, we found the desk, or we found someone who has broadcast, and then we continue. So the default role of a robot is worlds, and then for this position that this robot will keep coming back to. So that's the one position that they will always go back and forth. The will set later. See what we are trying to, yes. So that's what we started with. So then we have these let's see, if we haven't found a desk, then we try to find a desk to assign this robot to. I'm trying to figure out, so we have this break. Okay, sorry, I'm zoning out a little bit. I'm trying to figure out if this is false, but this is also false. Oh, that's not true. Okay. All right, so that cannot be both false. So if we haven't found a desk, then we go through all the focus zone children and see if one of those items is a desk zone. And if that's true, then we set the desk to that specific item. We give the robots the role of desk, and we figure out the X and Y coordinates of this desk and put that into the persistent position variable. Now, because we have set this variable, that means we will not be going into this piece of code because this has been set. So if we don't have a desk zone, or if we already found a desk before, then we are going into this code, and then we do the same thing, but then for the broadcast zone. We'll loop through everything until we find a broadcast. So then we initialize a new robot with the user ID that we have that's being passed into the create robot thing. SID is that. And then the default world sizes and its new role that we have found. So that will be either like the broadcast or something. If we have a persistent position, so that is if we are either desk or a broadcast robot, then we set that onto this new robot that we created, and we push it into our robots array that we have. And since robots is just an extension of a user, we add that to the same container that already contains the users that we have or will have. I hope that's clear so far, and if not, please let me know. Okay, so we go through this. Okay. So I'm guessing, so let the update, yeah. So in the update function, if you remember, this is the function that will happen on every tick. So it will go through a long loop, and every tick it will update. It will do this update function. For example, if you want to move your user, your local user around, or something like that, and the other users as well. So that's the part where we also update all the robots. I was just checking where we want to go next, so that I don't skip over a thing. So one of the functions that we are calling here is robot.update. So that we do that for every robot that's in the list. And here we calculate the distance to their target position. So I'm guessing the target position is what if we don't have a target position? All right, let's go back into the blog. Let's see what Lisa says about this part. Did we already talk about target position before? All right, so if you have a persistent position, then that would be the target position. What if we don't? No, that's not true. Pick new target position. So this is way later than where we are right now. So X and Y is 0. The default target position is 0, 0. Okay, sorry, I just saw your message, Lisa. Yeah, so this is the default target position. So that's where we are going first. So we're going to this is X0, Y0, the center? Probably not, right? So first we go to X, Y0. And so we calculate the distance to that position, and if it's higher than 5, then we're stepping to the target. And stepping to the target, as you can see here, is basically a calculation to just take take a little step into the 2D world. The top left, okay, X, Y is of course the top left, not the center. And if we reach the target, if we let's see, if this does reach target as at is empty, let's see, reach target at. So if reach target at is empty, which it is by default, then we say we reach the target right now. Is that true? So we're always taking if it's not empty, then all right, let's go back into the block. I'm curious about this. Robot is more than 5 pixels away from its target position, and we have to step towards the target. That's with this. We calculate the angle and the velocity the robot needs to travel to step towards the target. Because robot class extends the user, uses the same default speed of 4. We can tweak it. We can also tweak it. Can we tweak it specifically for? Okay, we can also probably tweak that speed specifically for the robot. If it's less than 5 pixels away from the target position, we register that it has reached its designated spot. That is somewhere else. If it has been in that spot for less than 10 seconds, we're early out. And then pick new target position. So we register, okay, Lisa says yes. So we register when the user reaches the target, and then it waits there a while before continuing to navigate. So, oh, so I missed just a little step. Okay, I get what I had wrong. I forgot that this says return. So if the distance is bigger than 5, we will always just only step to the target. I missed simple return here. So and then so when it is closer than 5 pixels to the target, we say okay, don't need to go any further. You have reached the target. And we say if you haven't reached the target before that, then the target then we have reached it right now. If this is not empty, then we want to wait for about 10 seconds. Reach target at is less than 1000 times 10, 1000 milliseconds times 10. And then if that is finished, so if we've waited for 10 seconds, then we say, okay, we pick a new target position and we clear this reach target at. Sometimes it's the littlest things, right? So I just didn't really register the return, even though it's bright yellow. Anyway, if we say we want to pick a new target position, so here it's when it's get interesting. Well, the rest was also interesting, but here it's like when you, after they first went to the top left, then they go into the new position. So if they have the world role, so that is any random spot within the world, we say that the new target is a random number between x and y. Did we create our own random function? Yes, we create our own random function, and I went into that in a different different video. So if we're not in the world role, we want to toggle between persistent position and the spot just above it. Okay. If distance to the persistent position is less than 5, okay, so so we want to have them go into the position, so into the desk or the broadcast zone, and out of it, and then in it, and then out of it, and we're gonna go keep doing that on and on. So here it checks if it's in this position, and if it is, then we wanna update that with like 3 times its own width. Just above it, you say, but isn't this just to the left of it? Or am I seeing this wrong? X and oh no, Y, sorry. Wow, it's late. I really need this 3-week vacation apparently, and for a second I thought that Y was definitely the x-axis. Sorry. So yeah, so we go, shouldn't this be height? I don't know. That's I guess that's what confused me. So we put them like 3 times their own width above the target position, and then we go, and if they are not in that position, then we just go back to the persistent position. Lisa says it's a square, so this should be fine, but we could also make it height. I agree. And then after the update, we also check the focus zones, which is doing a try interact. Close desk and file this overrides the user focus zone check. Okay, so we have I think I saw a little bit about there. The check focus zone method reference above simply iterates over the zone collection we pass to the robot and calls try interact on the zone object to handle the robot joining or leaving various zones. So we talked about that in a different blog, but we're basically trying to, different video. Basically, that's when we want to interact with the focus zone, and we want to do that for the robots as well. So we want to handle it joining and leaving these rooms. Let's see, where were we? Pick new target position. Yes, we already have done that. Oh, we are going through this this blog post really fast, but that's fine, I guess. So we're now into unit and integration tests. Let's see if there's a way I can show you how it looks. Let me check for a second. I can of course just fake it. Let me just fake it by creating a fake user. That is probably not correct. there it is. There's the robot. That's the robot that's going to the, wait. Goes all the way to the top left. And then it waits there for 10 seconds. And then it just goes back to a random position in the world because, or no, this one should go to a room, right? To the first desk. So it goes to the desk, and then you can just wait, and then it goes up and down. And this is me just faking real robots. It goes up and then it goes down again. All right. This is of course not how you should be doing it. You should be creating your own headless robots to test. And we have discussed how you can do that here. But right now, let's just go further into unit testing. So, yeah, let me just quickly share this link into the chat. Here we go. And I will also share it in the YouTube video if in case you're watching YouTube, and it will be in the description down below is how the cool kids say it. So this was the robots part. And let's go into the next part, which will be the unit and integration test. So this is a little bit more than just the robots part. This is all automated testing. Maybe you're here for the automated testing. Maybe you thought the robots were going to be cute. Too bad they are not. They're just robots walking around. By the way, you can use those robots for any kind of thing that you're trying to build, of course. So just check out that blog about headless robots and to give you a little bit more inspiration about how to use those robots. So unit tests, if in case you don't know, there's we have unit and integration tests. So unit tests are there to validate behavior. So small functions. Integration tests is interaction between components and can execute multiple functions as well. And we'll show you a little bit of both. So let's just go into running the tests. You know, I am going to leave all the calls here for a second, just so that I don't have anything running in the background. All right. So let me kill. Should I kill this or should I? No, I will kill this. npm run test. I'm going to make this a little bit bigger so that you can also see what's going on here. So as you can see, we're using Jest for this, and it runs so. It passes everything, gives an error, but as you can see, there is some WebGL things that are not available, and then silently failing. Then we have a collider test here that tests a few things. We have the zone tests and the distance tests and gain and pan tests. You'll see an output that looks like this. I do not. Mine is not this pretty. Why is mine not this pretty? I still have a test output, but it's different than what we have here. Is this a newer version or an older version? I don't know. Should I have things not installed maybe? No, this looks fine. Is it this error? Looks like coverage reporter is failing. You must provide the URL of lib/mappings.wasm by calling. Huh. I am going to Google this. I have some extra time, so this would be might be interesting for you to also see how I figure this out, but it's just Googling things. Okay, so getting the same kind of error. Because the lack of coverage tables. Yeah, So Lisa cannot reproduce it on her end. Maybe it's just a thing on my end. Let's see. It's probably, maybe it's my Node version. 18.7. I don't know. Let's see what they all say here. I did remove nodes modules today, and should I maybe I added it as a dependency. I'm just gonna see if adding source map as a dependency. Is it source map? It is source map. Let's see if adding source map as a dependency fixes it on my end. Who knows? Yeah, that fixes it. I don't know. It's weird. It's probably, I think maybe V8 Istanbul uses a different kind of version of Node or something, or a version of source map that is not compatible with what I have. If you have this problem, you can install source map. Apparently. So here you can see what on this table, you can see how much we're currently covering. As you can see, we're not covering anything. There's some lines that it can clearly see that we're not covering. There's some functions that we aren't hitting on all the files. Yeah. We'll just add this as a def dependency, probably. Why is it saying that it's playing? It shouldn't be playing anything. Anyway, just gonna clear this for a second. Okay. It's still not as pretty as this, but it's prettier. So, okay, so it says here there was one main challenge that we ran into when testing the functionality of our spatialization app. Current testing frameworks don't yet seem to provide very comprehensive support for the web audio API, as well as for RESTful tests like media stream track. To test parts of our code which interact with these types, we ended up having to implement a few of our own mocks. I know that there's some things that should work now. For example, here we are talking about how standardized audio context mux doesn't seem to provide a full mock for the stereo panel node. We heard that it should work now, so we'll update this demo at one point to reflect that. So I'm not gonna go into this bit because it's slightly outdated, but mocking things is something that you just have to do a lot when you're creating tests. So it's basically faking certain APIs. So there's two things that we use here, and that's Jest and JS DOM. If you haven't used both or either one of them, JS DOM is let's start first with Jest. Makes more sense, of course. Jest is a testing framework that allows you to do all the automated tests that we are doing. And we need to create a DOM for all the DOM is, by the way, document object model. It's what the browser uses for their HTML, but we don't have that in Jest. So we need something that fakes that, and that's where JS DOM comes in. So you don't have to open a browser. Otherwise, there's ways to run tests with real browsers, but we are using a fake one, basically. So there's some DOM elements that we use in the application. The Jest DOM doesn't support yet. So they are these media stream track, media stream RTC peer connection, and the play method on an HTML media element. So these are all, most of these have to do with audio and video. Well, all of them have to do with audio and video. So these are for our tracks. This is for the users track. This is for echo cancellation. And this is for playing audio and video tags. So we are going to mock a few of those. It says the implementation can be seen here. Okay, so we're not gonna do the other ones because they're very similar to media stream track and RTC peer connection. So where are we? So we have a folder here called tests, and here is where we do our tests, right? So we have our collider, distance, gain, etc. What you saw in the beginning. So here we have our mocks file that is mocking all our tests. And the first thing that you see here is media stream track. And the whole mock is this. So it is an object. So we say object.define property. Okay. Going into the code. It's weird to do the code things in the block. So there's this the object.define property. So basically we say on the default window object, we give it a media stream track property, and that media stream track property is writable and has a property called value, where we sort of fake a function. So jest.fn.mock implementation is faking a function. We're not doing anything with this. The only thing that we're doing is saying, okay, if you call this media stream track.value, we just run a function that does nothing. So we don't need to do anything more than that, because we need to use that for our tests. We don't want to test the media stream track functionality itself. So this is very small, and as you can see, media stream is also sort of like that, but then also with mocking a return value of an empty array when you want to get audio tracks. Then we have the play, which is mocking this get function. But what we also want to mock is what we talk about is this RTC peer connection function, which has a callback function, where we're using these other fake functions, right? So let's see what Lisa says here. RTC peer connection requires some extra handling because we directly call to some methods on the class on our code. We need to make sure we mock those too. So we have this value, and that value as a callback function where we also use these start, create offer, create answer, etc. Are we actually using those directly here? Yeah. So if you go into this, the loopbacks TypeScript function, you can see that there's this the RTC peer connection thing that we are mocking, and we are using this create answer that we get back. So we also want to mock those, otherwise we will get errors in our tests. So something quite a little bit bigger is mocking the web audio API. Jest doesn't currently support mocking the web audio API. So we need to create something. So it provides mocks for various web audio API classes, and that allows us to instantiate a mock audio context. So this is what I said before, that let me quickly see. Maybe it's still interesting. Is it how much? It's 8:52. Let's see what else we have later. Okay, so maybe we don't want to go into the whole mocking of the web audio APIs, mostly because we don't really need to do as much in it anymore because of Jest fixing that, or okay, so we used the standardized audio context mock package for the web audio API, and it doesn't provide a full mock of the stereo banner node. All right, so if we step into audio context from standard, we can see that it creates. Okay, so if you want to know how to add things to something like the standardized audio context mock, then go into this this part of the blog if you're really interested in it. But you don't need to worry about this right now because it should be fixed. If it's not, then well, then this would still be interesting. What's more interesting, of course, right now, maybe for the last couple of minutes today, is mocking the body and then creating the functions. So let's skip over this a little bit. So it's not that big, by the way. So it's not like a huge implementation. It's just adding the stereo panner to it, but that's all the stuff that we need for it. So mocking the body is like these are the elements that we need for our tests. So we just give this as an inner HTML to the body. You can add a lot of other stuff to it, but this is the bare minimum that we need. So we don't want to do more than that. We won't go through every test case in this post, so don't hesitate to contact us if you have any questions. Instead, let's go through one test case of the banner tests. Okay, let's go do that. So we have the pen.tests.ts, and what do we want to go? Speaker on the max left of the listener. Okay, so we have, in case you've missed it, we have a panning, so you know when a user is either to the left of you or to the right of you. Am I doing this right? Yes. To the left of you, to the right of you. I know the difference between left and right. It's just I don't know how you see me. I'm not sure if I'm mirrored, but either to the left or to the right of you. And we want to see if we can test this. So we have the audio context with the fake the mock audio context, and then we create a new user. So we create a user with the ID of local. We have an X and a Y, and we say that local is true. So this is the local user. And then we add the earshot distance to 100. And then we have a remote user who is on. Okay, so earshot distance is when is someone in earshot distance, how many pixels. Just needed to remind myself a little bit. Then we have the remote user, which has an X of 0 and a Y of 100. So it's on the same Y-axis, but not on the same X-axis. I'm doing it right, correct. So we want, let's see, and we have a audio track that we create, and then we want our pen to be -1. So -1 is all the way to the left, +1 is all the way to the right. So we have a get audio mod function for the local user, that is this one. Let's see what that did again. And we call a user's private get audio mod method also via string index notation, passing in our distance between our users as well as the remote user's position. We check if the pen value we got from the function is what we expect via the first expect call. Are we seeing why we're using the string index notation? We reference the remote user's audio track variable via string index notation. This is because audio track is a private variable and Typescript will, as it should, not compile if we try to access it via the dot notation. Accessing private variables through string index notation is a purposeful escape hatch. I did not know that. That is interesting. Thanks for this tidbit. So basically that means that if you shouldn't be able to access private variables with Typescript, but they decided that if you really, really want to, then do it like this. I hope that people are not abusing that, because that would take away sort of the use of TypeScript. But yeah, don't tell your developer who just wants to get things done quickly. Okay, so back to the code. So we say we want to be so we get the audio mod. What did I do again? I'll use private get audio mod method, passing in our distance between users, as well as our distance between users, as well as the remote user's position. So we have our distance. Okay. Anyway, that is what it's supposed to. Sorry again. That's how we calculate this. If we are in earshot distance. This does in earshot distance. So if someone is in earshot distance, yeah. And if it returns the pen that we want it to be, then we say, okay, we expect penner mod.pen to be -1. If that's like, if we do this, I can show you. Then we'll say, whoop, this is wrong. We say we want pen to be 1, but we're receiving -1. Local process users remote. So then we're processing the remote users. And we're doing the same with the node chain. So we want the node chain to be -1 as well. To ensure, okay, so finally in the test case above, we call the users process user method, which will go through the proximity check live check we went over in the previous post in the series. This includes calculating pen values and modifying the stereo penner node in our node chain to match. To ensure that this happens correctly, we want to access the private node chain variable in the user media instance, and that's here, and the call get pen to retrieve the pen value from the stereo penner node. Then confirm that the pen value is -1, and as expected via another expect call. So this is how we're trying to replicate basically the users, and then also call the functions that we normally would call if someone moves into a certain distance. And then and if they are within earshot, we are using that node chain to figure out if it actually works. So if we are doing this get audio mod and we have done something weird here where we do something like this instead, then we know that something goes wrong because one part fails. A lot of things fail right now. So all of these get audio mod only fail, right? But what if this one works, but the node chain is doing weird things? We don't, of course, do that because I don't think, because yeah, so for example, if we accidentally did something like this, so we want to test both versions of getting the pen. Okay. Just to make sure that everything still works correctly. That's basically how you create these this integration test. So yeah, I feel him. Okay, so this was the last part of let me go back into a proper camera for a second. So this was the last part of the spatialization demo. So we've gone through everything from start to beginning. We explained every last bit of how that very good demo works. If I may say so on behalf of Daily. If you enjoy watching this spatialization series, if you think, well, this was very useful to see it being explained instead of having to read it all, so that you can just hear it in the background, let me know. Reach us through Twitter, reach us through my or Daily's Twitter, @trydaily, @Jayne_Mast. Those are the Twitter handles, or just contact us through the contact page on the website. We would love to hear about it. Or if you're watching this in YouTube, just add a comment to one of the videos. If you don't like it, we also want to hear it. We want to, of course, improve our streams as well. As I said in the beginning, I will not be streaming for the next 3 weeks, maybe even 4, but probably 3 weeks. I will be back by then on from vacation. So I hope you have enjoyed this series, and I hope you look forward to the next one. And I'm also going to keep continuing doing my OBS replacement live streams. Of course, not during my vacation. I have different things to do. Yeah, thank you for watching again, and I hope you have a very good day. Hope you have a good Wednesday, and I will see you next time. Thank you. Bye.